This video will cover multiple choice problems 6 through 11 on the first page of the review packet for module or unit 2, excuse me. So for number 6 here, you are going to use the power rule to differentiate. So you bring down the exponent of 1/2, multiply by 2, and then you drop a degree to the negative 1/2. Now on the next one, you have a coefficient of negative 1/2, and then you have the degree. If I rewrote this term up here, it would be negative 1/2 x to the negative 1/2. So if I bring down that negative 1/2, I multiply here by another negative 1/2, and then I drop a degree to negative 3/2. So let me clean this up. 1/2 times 2 goes away. So I have my y prime equaling x to the negative 1/2, which is 1 over the square root of x. Then I have a negative 1/2 times a negative 1/2, which will be 1/4. And then my x to the negative 3/2 flips underneath to become a positive exponent. And as I look here, I believe that my answer should be D. Question 7 is a straightforward question and then a tricky little thing you have to do at the end to match to the correct answer. So we have a chain rule situation here. We have the outside function as the square root of x. So we bring down the 1/2, and then leaving the inside function intact, we drop a degree to negative 1/2. Then we'll multiply by the derivative of the inside function, which is 2x plus 2. Now when I clean this up, the 1/2 and the 2 go away, so my y prime is now x plus 1 divided by the square root of x squared plus 2x plus 1. And I bet you got that, and you looked over here and you didn't see it as an answer. But what you need to be able to notice is that, wait a second, y equals the square root of x squared plus 2x minus 1. So all they're doing is subbing in y for that square root in the denominator, and your choice ends up as A. Number 8, we need the quotient rule for this problem, so let's go ahead and do it. We have low, which is the square root of 1 minus x squared, times d high, which is 1, minus high, and then d low will be 1/2, then 1 minus x squared to the negative 1/2 times the derivative of 1 minus x squared, which is negative 2x. So that is low d high minus high d low. And then I'm going to square the bottom. So the square of the square root is just 1 minus x squared. And this is y prime here. So we have a lot of cleanup work to do here. So let's work on that. Going to come all the way up here. We have the square root of 1 minus x squared. And then if you notice, my two negatives will make a positive. My 1/2 times my 2 will go away. So I have an x and an x. So x squared over the square root of 1 minus x squared. What I did there was take this negative exponent and flip it underneath the fraction. Now I'm still working to try to find out how to match one of my given answers. So I'm going to find a common denominator in my numerator by multiplying by the square root of 1 minus x squared over itself. So my numerator then becomes 1 minus x squared plus x squared divided by the square root of 1 minus x squared, all divided by 1 minus x squared. So then look what happens. My x squareds cancel, and I'm left with 1 over, and I end up with 1 minus x squared raised to the 3/2, which when I take a look, I see this answer not represented, so my answer is E, none of these. Number 9. I have a chain rule situation here, and within the ln, I have a quotient rule. So first thing I need to do is to differentiate my outside function, which is the natural log, which means take 1 divided by everything in here. And when I take 1 divided by this fraction, I really want to multiply by its reciprocal, so I end up with e to the x minus 1 over e to the x. So that is the derivative of just the ln component. Now I need to multiply by the derivative of the inside function, which I need the quotient rule to do. So I have low, and then d high is e to the x, minus high, and then d low is also e to the x. Then I need e to the x minus 1 all squared to square the bottom. Now let's start to clean this up. I have one factor of e to the x minus 1, which removes one factor of it from the denominator. And then I have an e to the x, which canceled off of both terms in my numerator. So I'm left with e to the x minus 1 times e to the x all over e to the x minus 1. And I'm sorry, let me erase that numerator. In the numerator, I have e to the x minus 1 minus e to the x, because I have a minus there. So my e to the x's here cancel, and I'm left with negative 1 over e to the x minus 1, so my answer is B. Excuse me, but my answer is C, because I have a negative here and there's a negative here, so my answer is C. For number 10, I have an arctan function, and you all need to memorize that the derivative of arctan is 1 over 1 plus x squared. So what I need to do here is take 1 over 1 plus, and it's all of x over 2 squared. Then I need to multiply by the derivative of x over 2, and x over 2 is really 1/2 x, which is linear, and the slope of the line is 1/2. So when I multiply this all out, I get 1 in my numerator, and in my denominator I get 2 plus x over 4 times 2, so that is 1 over 2 plus x over 2. Now I don't see that, excuse me, I have an x squared over 2. Sorry about that. I don't see that, and I also have a problem with this right here. I don't need a fraction, so I'm going to find a common denominator in my denominator. So now I have 1 over 4 plus x squared over 2, and instead of dividing by the fraction, I will multiply by the reciprocal to get 2 over 4 plus x squared as my y prime, and my answer will end up with E. Moving on to the last problem on the page, once again I have to take the derivative of the inside function. So in order to differentiate the natural log, I'm taking the derivative of the outside function, ln, leaving the inside function intact. So I need 1 over everything in paren, so 1 over secant x plus tangent x. Then I have to multiply by the derivative of secant plus tangent. Derivative of secant is secant x times tangent x. The derivative of tangent is secant squared x. So now I begin my work to simplify. I'm going to have, I can pull out a secant in the numerator to be left with tangent plus secant. Ooh, and that's very nice because my denominator was secant plus tangent. So that means I can simplify by knocking these out, and my final answer for y prime is the secant of x, or choice A.